10.5, abuses of statistics. Did you know people manipulate what you think and believe all the time through their own abuses of statistics, either intentionally or sometimes maybe unintentionally? So I'm going to talk a little bit about the two different types of abuses. One of the abuses has to do with how people are asked questions. These are some of the things that are useful to know when you're comparing information that somebody's given you or trying to consider information. Who was asked? So, if you ask everybody at OBU who they're voting for president, you ask everybody at the University of Berkeley, California, do you think that you're going to get different answers? Probably so. So, either scenario is probably not a very good reflection of the nation at large. Not only that, but you guys are all young, which means your answers are also going to look different than maybe your parents' answers might. How many people were asked? Okay, if you ask 100 people and you ask 10,000 people, you might get something that's quite different, right? Maybe you just happen to pick the 100 people that are in a bad mood that day, right? I mean, like, that's more possible than picking 10,000 people that all happen to be in a bad mood that day. How many responded? I'm sure you've never received a survey that you've just thrown in the garbage, right? I mean, I know I haven't. Right? It matters. Did only the people who responded do so because they cared? You know, they had a very strong opinion. They really, really, really wanted to? Quite likely. So maybe you're not getting a very accurate reflection of everybody because half the people or more chucked it in the garbage before they even looked at it. Was the sample random? Okay? If you ask everybody on OBU's campus, that's not a very random sampling. Right? But if you stand at Shawnee Mall, it's going to be much more random who comes in and who answers it. It's not going to be everybody in this particular group of students, right? How is the question worded? You have to be careful. If you word questions in certain ways, somebody might be tempted to answer it in a certain way, either because your question's confusing, right? You used the word not in there 3 times, so they don't even know what you asked them. That's a possibility. Or maybe you ask the question in such a way that they feel uncomfortable being truthful, right? So if on campus right now you asked everyone in this classroom, did you drink alcohol last weekend? You might not feel comfortable answering that question honestly because the content is actually a little bit uncomfortable for you. This is sampling processes. Graphical representations can also be misleading. We keep talking about having titles, and I haven't really talked too much about it, but if your title's not on there, it might be that you've misrepresented something on purpose. You're trying to mislead. Labels on axes or all sections of a pie chart, same thing. It might look like something that's not really what's going on. The source of the data, are we talking about information from 2017 or are we talking about information from 2000? Because I'm telling you, if you asked the people in 2017 how many people have cell phones, it might be about 150% these days. That's what it feels like. Go to church with all these little children, and I'm like, seriously, the 5-year-old does not need a cell phone. All right? But if you asked people in 2000 how many people had a cell phone, it wouldn't be anywhere near that percentage. That's about the time when I got my first cell phone, and they weren't common in 2000, just so you know. Having a key to the pictograph or a stem and leaf plot, that's the same kind of a thing about the labels. Uniform size, I've kind of harped a little bit about that too, making sure everything looks like it's equally spaced. Uniform size on the symbols or pictograph or dot plot. Scale, if it doesn't start at 0, is it marked that way? If not, it doesn't start at 0. Is there a break shown? We encountered that last time. Another one, the evenly spaced numbers. 3D and 2D misleading effects. And I will actually talk about that. Does anybody have their textbook with them? I see Hannah's. Hannah, let me borrow your textbook for a moment. I want to give you an example of that 3D, 2D thing because it's very interesting, and unless I show you, you're not going to be able to know what I'm talking about. And I do see this one used as well. Okay. Do you see this page? It's on page 606. Do you see this pie chart here? Everybody see that pie chart? You may not be able to see if you don't have your book in front of you, but The 27% that's shaded in green at the bottom and the 23% that's shaded in blue at the top are almost the same. I mean, 23%, 27%, that's close values, right? Hannah, do those wedges look like they're the same size?
No.
No, like not at all, right? Because they've put in this weird three-dimensional perspective. Do you guys see it? The green at the bottom and that light blue near the top. When you three-dimensionalize things, it does weird stuff. The same thing happens on this piece right here. If you take a look at this information and you're actually comparing, I don't remember what it was. The number of, it says 4 times. The data says that 4 times as many Corn Crisp cereal, 4 times as many Corn Crisp cereal is sold as the Sugar Plum cereal. Does this box look 4 times as big as the little box? No, it looks about 30-something times as big. I don't know. I mean, because it's got height and it's got depth and it's got width. I mean, it's got 3 dimensions to it. And really, this is just a one-dimensional comparison, right? I sell 1 box, they sell 4 boxes. That's not what this picture looks like. So 3D, creating something 3D that's not really 3-dimensional can also be misleading. So what you're seeing in this section of material with the homework is you're seeing questions that are related to how the data could be used in a misleading fashion. Most of it's not places where you're actually calculating anything, all right? It's asking you what's wrong with this. Why is this misleading, or how could it be interpreted incorrectly based on what's given? That kind of stuff. Make sense? Awesome.